This video is about reflecting telescopes. In the previous video, I explained how a refracting telescope works. In this video, we're going to look at the idea of why refracting telescopes are actually not much use to us in certain circumstances. So refracting telescopes really have a lot of problems. And then we're going to look at the idea of how a reflecting telescope works, because it overcomes all of the problems with the reflecting telescope. So the reflecting telescope, very much the solution to all the problems posed by the refracting telescope. So, firstly, when I am looking at a distant star whose light rays have spread out over a wide area, their waves that are arriving are going to be very, very weak. So very few photons. So very few photons are arriving at your eye from all those millions of light years, and therefore there's going to be a very weak. It's going to be what we call a weak object or a weak star or galaxy. Not much light comes from it because it's spread out so far on its long journey that very few photons get to you. So how do we look at stars which are weak? We look at stars which are weak by using the biggest telescope diameter possible. So if you want to look at a distant star, you want a telescope which has the largest possible diameter. Okay, so if you want to see weak stars, this is your preference, whereas this is not going to let many photons in. So you're after the biggest diameter, and we call this the aperture. Okay, so the bigger the aperture, the more photons can arrive. So we can do that by making the telescope nice and large, but that has its own problems. Problem number one is this. If I take a small objective lens compared with a large objective lens, the most immediate difference is the fact that the middle of the lens, for the large lens, is very, very thick indeed. So a large lens, which you need for a big aperture, is very, very thick glass. Because it's very thick glass, it will absorb lots of photons. So having a larger lens is counterproductive, because you make the lens bigger in order to absorb more photons, but at the same time the lens gets much thicker, and as the lens gets thicker, it means that all those extra photons you're absorbing that are passing in are going to be absorbed by the thick glass. They won't actually get to your eyepiece lens. So a large lens is thick, and therefore lots of the photons will get absorbed into the glass and not pass through. So you want to keep your lens as thin as possible, but you can't do that if you make it large. So large lenses aren't really much use. The large lens, as well as being thick, is also incredibly heavy because it's made of glass. Anything beyond 1 meter in diameter means that the lens itself will start to sag under its own weight. So I know this is an exaggerated version, but it will become more teardrop shaped simply because of the sheer weight of the glass. So you're limited by about 1 meter in diameter anyway for a glass lens. So going large on our lenses has a number of problems. One is it's thick, which means the photons won't get through it. Number two is it will sag, and it will then distort the image, which is no use either. Third reason why it's a problem is to do with the edge effects, which is known as chromatic aberration. If I just draw the tip of a very thick large lens here, so this is the top of the lens, you can see that looks very much like a triangular glass prism. Now, a triangular glass prism will bend light of different colours by different amounts, so that as my white light comes in, which is a mixture of red, orange, yellow, green, blue, indigo and violet, the red rays will bend less than the blue rays. So the red rays will be brought in like that. The blue rays will be brought in sooner, and then obviously in between all that you'll have your orange, yellow, green, blue, etc. So if I just stick a yellow in there to give you an idea. Now, this is a problem because you cannot get all of the colours focused at the same point. The colours will focus at different points. So if I draw the whole lens like this, so the reds will focus here, and then the blues focus a bit nearer the middle. So I've got my blue rays focused here, my red rays focused here. That's my principal axis. So I'm going to get a horrible mixture of the colours, and that's known as chromatic aberration. So three reasons not to use a glass lens on a refracting telescope, and in a large telescope, is that the lens will be too thick, the lens will be too heavy, and you will get all of this chromatic aberration. So the solution to that is to make a telescope that brings rays together by reflecting them instead of refracting them. So a refracting telescope works on the principle of having a curved mirror. And that's the symbol for a mirror. Now, a curved mirror does exactly the same as a lens in terms of it brings light to a focus. It's just that it brings light to a focus on the same side as the object, as opposed to the refracting telescope, which brings the object to a focus on the other side. So these will reflect, and there we have my focal point, and the mirror has its own focal length, just like a lens does. But it has a number of advantages over the refracting telescope. If we take the issues in turn, so if I want to scale this up to make a larger mirror, I can do that. Now, one individual mirror might be very, very heavy, but there's nothing wrong with making the mirror in smaller sections, such that each small section is not going to be heavy enough that it sags, and they're very thin, so the size of the mirror doesn't really affect how thick this piece of reflective material is, and therefore I'm not going to get those sort of scaling up issues. So you can make it large without any worries about distortion. It doesn't have the same effect in terms of the chromatic aberration because, again, it's just reflecting. So there is no chromatic aberration. That problem has been solved. And generally speaking, you can scale up mirrors as much as you want in order to get the biggest telescope that you can in order to look at the weak, weak images. So you can go up to several meters in size. You can make it in sections so it's supported, whereas one giant glass lens has all those different issues. So it's the reflecting telescope that is the one which is most commonly used. Now, normally a reflecting telescope is housed in a tube where the mirror is at the back, and then the light is brought to a focus, say somewhere like that, and then there is another mirror here which then reflects those rays out towards the eyepiece, which is in the side of the telescope itself. So that's a reflecting telescope. It has advantages over the reflecting telescope.